Okay, so in this video, I'm going to go over reference angles. And so within 62-day one notes, I'm going to look at the back page, which is identifying reference angles. So we're going to do two different types of examples that correspond to reference angles. So reference angle is the acute angle formed between the terminal side and the x-axis when the angle is in standard position. So for any angle in standard position, reference angles are located where they're touching the x-axis. So reference angle would be here, a reference angle would be here, a reference angle would be here, and a reference angle would be here in the various quadrants. So it's always that acute measure between the x-axis to some ray that corresponds to a part of the angle in standard position. So notice that these are not in standard position. However, the angle that we're looking at is in standard position. So to find the reference angle for any angle, we want to first sketch the angle and consider which quadrant the terminal side lies in. And so when we're doing this, what we want to think about is where does that measure lie, right? So if I think about the quadrants like we did when we were sketching angles, in terms of degrees, this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and then all the way to 360 degrees. So again, I kind of do have more rotations, and I might have to think about angles that are larger than 360, but I would just find the coterminal in that case. I also might end up with negative angles in some manner. And so what I want to think about is if I have negative angles, what changes is that this 270 is equivalent to negative 90, 180 and negative 180 are the same. And then 90 and negative 270 are in the same location. And then 0 and negative 360 are in the same location. So technically that's negative 0, even though that's not an actual value. So when I'm identifying these, if I have a positive angle, which I have here, I'm really just looking at which quadrant are they in. So 130 degrees is, if we think about it, between 90 and 180. So that's in quadrant 2, which means that in order to find the reference angle, what I'm going to do is I'm going to use the formula 180 minus theta, because that's my formula for quadrant 2. So I'm going to do 180 minus 130. And so that tells me that the reference angle for that quadrant is 50 degrees. So then 210, if I think about it, is larger than 180, but smaller than 270. So I'm in quadrant 3. I should use Roman numerals. And then, so that means that I'm going to take my angle and subtract 180. So I'm going to do 210 degrees minus 180 degrees. And that's going to give me my reference angle of 30 degrees. Okay, so the reference angle for 210 is 30 degrees. So again, that's telling me that if I were to find 210, I'm going to the line that divides quadrants 2 and 3, and I'm just going 30 more degrees is what reference angle does. So coterminal angles are two angles that have the same terminal side in standard position. And so what we're going to talk about is that I can find positive and negative angles that have the same reference angle. So this is why we looked at the values here being positive or negative. So we're going to look at the positive first and then talk about how we can find that negative angle. So if a reference angle is 45 degrees and the terminal side lies in quadrant 4, we're going to draw a picture. So if I have a angle in standard position and they're telling me that in quadrant 4, so I'm in this quadrant over here, the reference angle is 45 degrees. So they're telling me that the N side here gives me a 45 degree angle there. So that means that I can think about this value as being 360 degrees minus the 45. Okay, so my angle would be 360 degrees minus 45 degrees would give me the appropriate angle, which is 315 degrees. And so this would be my positive angle. If I want to find a negative angle that goes along with that, what I would have to do is add or subtract 360. So in order to make a negative angle, I want to subtract 360 from 315. Okay, so what I would do is I would do 315 degrees minus 360 degrees. And so that would give me a value of negative 45 degrees. And that's going to be the value for my negative angle. And so when I'm doing this, I can always add or subtract 360 degrees to find angles that are coterminal. So that's our strategy to find coterminal angles, is adding and subtracting 360 degrees, kind of to get what we want. And so for part D, we have a reference angle that's in quadrant 3. So if we draw the quadrants, we're in quadrant 3. And they're giving us a reference angle of 20 degrees. So in quadrant 3, it's in reference to always the x-axis, so that's 20 degrees. So what I want to think about is if my angle is in standard position, it's going and starting here and then hitting this. So it's 180 degrees plus the 20 degrees is going to give me the positive angle. So that means that I'm going to have an angle of 200 degrees that has that reference angle. And then similarly, I'm going to take my 200 and I'm going to subtract 360, and that's going to give me the negative. So if I do 200 minus 360 degrees, that's going to give me negative 160 degrees as my negative value. Okay, so the negative angle would be negative 160.